Real numbers. Real numbers are the numbers that can be written in decimal notation, including those that require an infinite decimal expansion. There are many types of real numbers, including whole numbers. These are numbers that are positive whole numbers, negative whole numbers, and zero. Things like 1, negative 10, 15, 0, negative 35, etc. Rational numbers. These are numbers that can be expressed as fractions. So things like 5/2, or 6/10, or negative 21/30. These decimal numbers will eventually terminate or repeat. To be aware, though, that all integers are also rational numbers, because we can write a number, for example, 4, as 4/1. Another type of real number is called irrational numbers. An irrational number is a decimal number that never terminates nor repeats. So things like e, pi, √2, these are all irrational numbers. If we take the irrational numbers and the rational numbers and we merge them together, that gives us the entire set of real numbers. When we want to do any arithmetic, we need order of operations. We often use the acronym PEDMAS. This stands for parentheses and fractions, exponents, multiplication and division, and addition and subtraction. When we talk about parentheses and fractions, we want to calculate the values of all expressions inside a bracket first. When dealing with a fraction, think of the entire numerator and the entire denominator, each as being their own brackets. So we calculate the numerator and the denominator separately. Exponents. We want to raise all numbers to the indicated power. Third, we want to deal with multiplication and division. We want to deal with multiplication and division as they're shown from left to right. And finally, addition and subtraction. We want to do any remaining addition and subtraction again in order from left to right. Example, 4 plus 6 times 2 plus 3. We start with our brackets. 4 plus 6 gives us 10. We then have 10 times 2 plus 3. Then, now that there's no more brackets and no exponents, we do multiplication and division from left to right. So 10 times 2 is 20, and 20 plus 3 is 23. Another example, 4 minus 6 times 2 times 3. We begin inside the brackets again. 4 minus 6 is negative 2, and then we handle all multiplication and division from left to right. Negative 2 times 2 is negative 4, times 3 is negative 12. Another example. Here we've got some division. Negative 4 plus 6 divided by 2 plus 3. So we begin again with our parentheses. Negative 4 plus 6 is 2. And we get 2 divided by 2 is 1, plus 3 is 4. Another example. Here we have to be careful. The 4 minus 6 is not in brackets. Because there are no brackets, we deal with the fraction bar. 6 divided by 2 is 3. And we've got 4 minus 3, which is 1 minus 3, or negative 2. Be careful, not just when you're reading an example, but also when you're writing your own work. Be cautious of where you put your brackets, especially when it pertains to things like multiplication and division bars. Here's another example. Negative 4 divided by 2 cubed plus 3 over 4. First, we need to deal with our exponents. So 2 to the third is 8. Negative 4 divided by 8 is going to give us a negative a half. Negative a half plus 3/4 is 1/4. Your book talks about interval notation at quite a length. Subsets of the set of real numbers, which are unbroken segments, are called intervals. We can have the closed interval AB, for example. That's the set of numbers x, which are between a and b, but could include a and b. So for example, the closed interval 0, 10 is all numbers, including 0 and 10, in between 0 and 10. Open interval, with round brackets, is a set of numbers between our a and our b value, but it doesn't include a and b. You can see on our number line, we denote that we're excluding a and b with open circles. We can have half-open intervals. So for example, round bracket a, comma, b, square bracket. So this is a set of real numbers between a and b that does not include a, but does include b. Again, we denote the fact that we're excluding a by an open circle and that we're including b by a filled-in circle on the number line. We also have the half-open interval closed a, open b. So here you'll see that's a set of numbers between a and b where we include a but do not include b. So we've got a round closed-in circle at a and an empty circle at b, indicating that we're including a but not including b. We have some types of infinite intervals as well. So the interval square bracket a, comma, infinity, round bracket, is a set of real numbers that are greater than or equal to a. If we have a round bracket around a, that's a set of real numbers from a to infinity that are strictly greater than a. Similarly, if we're looking at an interval negative infinity to b with a square bracket on b, that's a set of numbers that are less than or equal to b. If we have a round bracket at b, that's a set of real numbers that are strictly less than b. The interval negative infinity to infinity is a set of all real numbers. Notice that anytime we have an infinity, we always use a round bracket.